Okay, so question number 4 from Kilbaha. A motorbike travels from rest along a straight line and accelerates in time, then brakes, then comes to rest. It's velocity time graphs. This is a velocity time graph. We have 3 components to it, and we have 3 different time periods to it. A and B are part of the middle. So since it's a velocity time curve, it's going to be continuous. So when it comes out of the inverse tan into the straight line, it's going to be the same y values on either side of the join of 120. So if I have over here 75 on pi and inverse tan of fraction x on top of 120, and math 3 given x equals 120. So coming out of the join, it's going to be at 75 on 4. And looking at the second one, I've got 50 on pi, inverse cosine of fraction x minus 240 over 120, and this time it's given x equals, on the join is 240. And that gives me 25, so 25 on the join. So to be able to solve for A and B, I'm going to say that 75 on 4 equals, when t equals 120, A plus 120 times B, and 25 equals, when it's 240, A plus 240B. Solve for A and B. So do that on a calculator here. Math 1, simultaneous equations. I've got 75 divided by 4 equals, I'm going to use x for A, x plus 120y, and 25 equals x plus 240y. Solve for x and y, and I get A equals 25 on 2 and B equals 5 on 96. Beautiful. Part B says sketch it. Okay, so what I might try and do first is sketch it using hybrid, so see what it looks like. So I've got 3 bits. I know my middle bit is going to be 25 on 2 plus 5 on 96 x instead of t, because that's the middle bit. And that's going to go from 120 x up to 240. So I've got, this is my first one, so copy, paste, and that goes from 0 to 120. And the third one is the inverse cosine, copy, paste, and it's going to go from 240 all the way up to 360. Press XE, I get undefined because I didn't call it anything, open up a graphing window, clear all that out, and then $75 on 4 is 18 and a bit. So I know at 120 we're 18 and a bit, and I know that at 240 we're at 25. And that's a straight line. Oops. That's a straight line. So if I change my window from -1 to 370 and -1 to 30, because I know the highest is 25, and I collect all of I select all of that, drag and drop, draws a pulley. So I've got a curve, and then I've got a straight line straight down to 360. And I've got 240 and 25, and I've got 120 and 75 on 4, and I've got 0. So there's my graph, there's my curve. Find the instantaneous acceleration after 5 minutes. 5 minutes will be 300 seconds, so it's obviously going to be negative. I might come here and go to graph format and make sure that the derivative slope is set. So then I'm going to do analysis trace, and I wish to go to 300. And at that point, the gradient should be, I didn't show, oh, there it is, negative 0.153. So negative 0.1531469. 3 decimal places, negative 0.153. I would otherwise have to take the derivative of the third graph and set x equal to 300 and go XC, and that gives it exactly, and that's the same answer. Part D. Find the distance travelled over the 6 minutes, 360. 2 marks, okay. So the distance is going to be the area under the curve. It's going to be the area under the curve. Going to be the area under the curve. If I come up here and I define that, so I've called it f of x. I wonder if I can integrate f of x from 0 to 360 with respect to x and get an answer. I did. 5791.99. So I'm going to say it's the integral from 0 to 360 of f of x. Was it called f of x in the graph up here? V of t dt, and my answer is 5791.999 to the nearest metre, 5792. I could do each of the integrals separately, but defining this as a hybrid function, I could then just integrate over the whole lot and determine the percentage of the time during the journey for which the motorbike is exceeding 60 kilometres per hour. So 60 divided by 3.6 will turn it into metres per second. So 50 on 3 metres per second. So if I come up to my graph, I'm looking at the percentage that it's above 50 on 3. So here's my graph. If I take my 50 on 3, I'm looking for the time. So analysis, G-solve intersection. My first time is at 100.69. 1. And my second time is at 300. So it's going to be above 300 minus 100.691. So the percentage that it's above will be 300 minus 100.691 all over 360 times 100 to turn it into A. So I'm going to have 300 minus, come back here, come back 1, touch that, pick that up, drag and drop. XE, the answer divided by 360 times 100 gives me that, which is my percentage, 55.363. 55.363%, going to 2 decimal places, 55.36% of the time. Done.